Looking here now at 4.1, we have writing an expression for coterminal angles here on page 76, question 9. So here we have 135 degrees. So an important thing about coterminal angles is that they appear the same, however, they're different angles. So if we think about 135 degrees, it would be about here. However, there's multiple ways to appear this way on a unit circle or any circle. You can either go 135 degrees, or you could go all the way around to here, which would basically be 135 degrees plus 360, or full rotation. You could also subtract 360. So our expression is going to look somewhat like this. Degrees n. And one thing you might notice is n cannot be a decimal. It can't be a fraction. It has to be a whole number. Because if we don't, we won't do a full rotation and therefore won't end up at the same point. So I'm going to say n, meaning n has to be an element of a natural number, or of the natural numbers. This is also what it means to label your variables. The reason why we use natural numbers is because we can't have 0. Because if we had 135 degrees plus 360 times 0 degrees, what we would end up with is just 135, which isn't coterminal. It's just the same angle. So again, coterminal is something that can appear as the same angle on the circle. However, it's different in its total degree. If you've moved ahead in the unit, or you learned general solutions first, with a general solution, it's typically written like this, where n is an element of integers. We can't do that here because if it can be an integer, that implies that 0 can be equal to n, which in this case we know is not true. So that is how we can write out an expression for all of the coterminal angles of 135 degrees. Notice how we use degrees here because the original is in degrees. Now if we move on to part B, where we get negative pi over 2, this is easily identifiable as a radian value. So we're simply going to do the exact same thing. However, now we use 2 pi instead of 360 degrees. So it'll just simply look like 2 pi n, and again, n stays as an element of the natural numbers, and that is our final answer. So if you're looking for any personalized or one-on-one help, you can check the link below.